log record buffering. Now, up to this, what we have seen or studied, that once the log is created, it is stored on the stable storage. What is the value in the log record? It is the transaction identifier, data identifier, old value and new value. So its size is very small. So output this every log record to stable storage at the time it is created. It imposes a high overhead on the system execution. Outputting this small value or small size record every time to the stable storage, where it is a remote site. Many times multiple copies are created in the stable storage. So for this simple or very small log record, every time it is writing to the stable storage, it is time consuming and costly. So it is desirable to output multiple log records at once. So for that, log record buffering scheme is used. Means what? Write log record to a log buffer in main memory where they stay temporarily until they are output to the stable storage. So on the main memory, buffer space is there. We know that to store the temporarily the disk block. So similarly, the log records are temporarily stored in the main memory, and then together they are output to the stable storage. For example, when the 100 log records are come together, all are stored to the stable storage. Instead of transferring single log record to the stable storage, group of log records are transferred to the stable storage, and before that they are temporarily stored in main memory in the buffer. So multiple log records can be gathered in the log buffer and output to the stable storage in a single output operation, reducing the IO cost. The order of log records in the stable storage, whatever the 100 log records, suppose we want to store to the stable storage, must be exactly the same order. Means if T0A 1950, then T0B 2050, then whatever the log record order, it must be as it is, exactly same as the order in which they are returned to the log buffer. Now, a log record may reside in main memory, volatile storage. Main memory is volatile for a considerable time before it is output to the stable storage. For some time it is in the main memory. So it may be periodically, or it consider counting the log records when 100,000 log records are generated, transferred from main memory to the stable storage. Means for that amount of time it reside in the main memory. Since such log records are lost if the system failure, power failure, anything happens, we may lose these all log records. Why? Because they are temporarily in main memory. So we must impose additional requirement on the recovery technique to ensure transaction atomicity. What? Transaction Ti enters the commit state only when the log record Ti commit has been output to the stable storage. When the Ti commit log record is output to the stable storage from log buffer to stable storage, then only transaction Ti enters into the commit state. Means it is completed successfully. Before the Ti commit log record can be output to the stable storage, all log records pertaining to that transaction Ti must have been output to the stable storage. Means if there are 4 log records, T0 start, T0A, T0B something and T0 commit. Before T0 commit, the previous 3 log records first return to the stable storage and then T0 commit. Before a block of data in main memory is output to the database, all log records pertaining to the data that block must have been output to the stable storage. Means what? Suppose we want to transfer a block from main memory to disk. Means suppose we are transferring data or executing the instructions on instructor file or student file. So after modification, that student file need to be transferred from main memory to disk. So before transferring this actual block where the actual data is stored from main memory to disk, the log records which are created related to that data are first transferred from main memory to stable storage. Means first logs are transferred and then the data is transferred, and that is known as write ahead logging. Write ahead logging means first logs are transferred to the stable storage and then the actual data is transferred to the disk. So that we call it as a log record buffering. Now database buffering means what? Some database blocks are kept in main memory. We know that buffer space is there, buffer manager is there, buffer management schemes are there. We call these are buffer blocks. For which purpose it is stored in the main memory? To avoid the transfer of disk. IO, to avoid the IO transfer or to reduce the IO transfer, these blocks are temporarily stored in main memory buffer. We call it as a buffer blocks. When a new block is needed, that buffer replacement policies already we have studied. Least recently used, correct? Most recently used, toss immediate, such kind of policies related to the database also we have studied. So when a new block is needed, if buffer is full, the buffer transfer, main memory transfer some blocks from main memory to disk to create the space for new block. And there this block is chosen according to some replacement policies. So along with that policies we have studied in the unit number 4, there are 4 policies. So only definitions are there. Force policy. Transaction would force output all modified block to the disk when they commit. Means whatever the data blocks which are modified by the transaction forcefully output to the disk, even if the space required is there or not. So it is more expensive. Why? Because every block is transferred from main memory to the disk which is modified. Force policy. No force policy. The recovery algorithm support the no force policy. Updated blocks need not to return to the disk. Not necessary that every time the updated block return back to the disk. According to the buffer management policies, it is transferred. Then no steal policy. The blocks modified by a transaction that is still active should not be returned to the disk. Should not be returned to the disk. Means this policy is called no steal policy. The transaction, the blocks which are modified by a transaction are active, not yet committed. If the transaction is not yet committed, it is active, then such kind of blocks are not allowed to transfer from main memory to the disk. This policy is called no steal policy. An alternative is steal policy. Allow the system to write modified block to the disk even if the transaction is not yet committed. But it is risky. In that case, a recovery is very difficult. In the steal policy, allow the system to write the modified block to the disk even if the transaction that made those modifications have not yet committed. Okay, so that part, how it is actually performed. When a block B1 is output to the disk which is on the buffer. Suppose the buffer block B1 we want to output to the disk. All log records pertaining to that block B1 are first output to the stable storage. Write ahead logging. According to the write ahead logging, first logs are output and then the block is output. It is important that no writes to the block B1 be in progress. Means no modification is progress for the block B1. All the transactions which are updated the data in B1 are committed. So before a transaction performs a write on a data, it acquires the exclusive lock. For that again the locking method is used. Before any write, the block is locked in exclusive mode. Then perform all the operation. And once it is completed, then the lock is released. Once it is completed, then the lock is released. So that given here in steps. Now the